We've spoken about travelling by car, but every day millions of people move much further afield by air, land and sea. But they might be bringing with them much more than just their luggage. For example, during last year's Ebola outbreak, there were concerns that air travel could spread the disease from West Africa to other countries, sparking a global pandemic. But were these worries justified? By studying the patterns of 187 diseases in 225 countries, Chris Murray at Imperial College has discovered that it's geography rather than air travel that's the most important factor, as he explains to Kat Arney.
One of the most striking results that really came out of this analysis when we got a glimpse of that first map when we look at the similarity of diseases between different countries all over the world, and it looks remarkably similar to the maps that Alfred Russel Wallace produced for animals when he was sailing around the world documenting pretty much for the first time where plant and animal groups were occurring and where they weren't. So that was a really striking finding to see that the world of human infectious diseases in some way reflects the world of biodiversity more broadly.
What is going on? What are causing these boundaries between different diseases? And are there some that traverse these boundaries and manage to go global?
What we think is rather than saying that the distributions of animals per se are causing these patterns of human infectious diseases, more cautiously we would say that probably the underlying processes that shape the distributions of animals and plants and biodiversity generally also apply to human infectious diseases. And the types of barriers we're talking about, things like big oceanic boundaries, mountain ranges, the types of things that animals and plants find it difficult to traverse. And on top of that, you have ecological processes, things like speciation, diversification, and it's the balance of these processes that create the distributions of plants and animals on the globe.
For the diseases that do break their geographical chains and manage to spread around the world, is there anything special about them that enables them to do this?
Yeah, so one of the things we did in the analysis, we looked at all of the diseases together, but then we also broke down diseases into different categories. So the types of categories that I'm talking about are things like vector-borne diseases versus human-specific diseases, which are diseases that can only replicate and transmit through the human population. We looked at zoonotic diseases, which are diseases that come from animals, and we looked at different disease-causing agents, things like virus versus bacteria versus parasites. And when you break it down in that way, you do see quite different patterns. Broadly speaking, what that analysis shows is that things like human-specific diseases and bacteria are much, much more widespread, whereas when you look at zoonotic diseases and vector-borne diseases and parasitic diseases, they tend to be a lot more restricted. And that's consistent with the idea that the diseases that do manage to overcome these biogeographic boundaries, it's related to that human specificity, whereas the diseases that find it more difficult to jump those biogeographic barriers are the diseases that are more rooted in their natural history.
There is a lot of concern that because we fly all over the place, humans are moving around all over the globe, thousands of flights every day, that we are basically germ factories carrying everything around the world. But your research would suggest that maybe this isn't quite as big a problem as we might be worried about. Is that the case?
I'd be very cautious to say that we shouldn't be worried about diseases spreading around the world. It's certainly true. We are germ factories and we are travelling more than at any point in our history. And I think that is a genuine concern. Infectious diseases demand our attention because very rarely they can have catastrophic and very, very large impacts. What I would say, however, is that this is really a rare event, so we really need to understand what processes are leading to some of those diseases being able to break out of these natural patterns, spread around and cause really significant damage. The other thing I would maybe say about that is that the natural boundaries to diseases help us manage that risk. So I'm not saying at all that we don't need to have biosecurity. I'm not saying we don't need to spend money on trying to control diseases at all. What I'm saying is that our efforts are in some way aided by the natural ecologies of these species because it is actually quite difficult for them to make these big transitions to become global pandemics.